Hello class, it's another Python session. Uh, Today we'll be examining lists and dictionaries. In this lesson rather, we'll be examining lists and dictionaries. So what are lists and what are dictionaries, and what are they used for? What are the operations we can perform on them? Now by the end of this lesson, you will be able to create lists and dictionaries and access items by index or key. Then you'll be able to modify collections with basic methods. You'll be able to loop through lists and dictionaries using for. You should be able to combine IO and conditionals and loops. Okay. So in Python, a list is a built-in data type used to store an ordered collection of items. So it's a data type just like we have the other kinds of data types, only that the primitive ones are the string, the numbers, and the booleans. Those are the primitive data types, right? They are the simple data types. Then the more advanced ones are these are lists, tuples, dictionaries, and set. So they are the more advanced ones. So there are mutable data types and there are immutable data types. So lists are mutable by default. They are mutable. So what do we mean by mutable data types? Now mutable data types, you can change their contents. Their contents can be altered, can be added, removed at will. That's what we mean by mutable data types. Immutable data types, on the other hand, you cannot alter their contents after being created. Now, let me get my highlighter now. So now, Python lists are ordered, right? They are ordered, so they can be indexed with the 0, 1, 2, 3. So the first item will be 0 as usual. Then they are mutable, meaning that they are changeable. Lists allow duplicates, meaning that you can have the same value, two or more the same values in a list. Lists are heterogeneous. What do you mean by that? A single list can store items of various data types. So in a particular list, you can have numbers, integers, numbers, strings, even another list. You can have different data types in a list. So lists are created by enclosing a sequence of separated items within square brackets. So that's how we create lists, and we'll explore that. So this is how you create lists. You have the name of the list, then you put this square brackets. Now this will be an empty list, while this is a list of numbers. So these are mixed data types. You have a string, you have an integer here, you have string, another string, then you have this another list here. You have another list here. So let's create our first string. Let's come here. Let's create our first string. I can say, did I say string? Sorry. Our first list. I say my list equals this, and if I print my list, so we get just this empty stuff. So but if I fill my list with numbers, so it's going to get this for me. It's going to get it printed out for me. Okay. So another way you can create a list is you can use the list function. I say my list equals list 1, 2, 3. Okay. probably we should have added a square bracket here. Let's rerun this. Alright, so that's how you create that's another way you can create a list. And just have this square bracket, then you put contents like this. Put content like this. Right. Okay, so let's come back here. So what are the operations we can do on a list? We can add elements. Now there are different ways of adding elements to a list. You can use the append. You can use append. So this is how you append an item. You can add a single. Now to append means to just add a single element to the list. So if I say my list, sorry, my list equals this empty list here. Like I say my list dot append, sorry, my list dot append 1. If at this point if I print my list, you know it's currently empty, right? It's currently empty. If I run it, my list is currently empty. So at this point if I print it again, you're going to have this. So it has added 1, right? Now if I add another item here, my list dot append, let's say for instance John. Remember, you can have different types of data in a list. If I run this, no, let's print it again. Let's print this again. Let's print it again before we run it. So print my list. So we have, remember, we have appended our John. So if I run it again, I'm going to have 1 John. So whenever you use append, now append adds whatever you pass into it to the end of the list. So that's why you have this John here. So it comes after all what is inside. If you have 10 items here already, to come after those 10 items. That's how append works. So we have extend. Now extend, what does it do? It adds all elements from an iterable, like another list, tuple or string, to the end of the current list, right? Okay, we have my list here. We can say my string equals let's call this, let's create a list called alphanumeric. Alphanumeric is currently unoccupied. Let's now call alpha, the alphabets. Now let's call it a string, right? A string. So let's put A, B, C, D, E, right? Now let's create a list called numeric. Numeric equals 1, 2, 3, 4, 5. It's got to have a comma. Okay, 1, 2, 3, 4, 5. So we can now say alpha numeric dot extend alpha. Let's pass alpha. Let's print it. Alright, so we have appended A, B, C, D, E. So again, we can also do that for the numeric. Dot extend numeric. So if we print it at this point, if we run it at this point, we have added A, B, C, D, 1, 2, 3, 4, 5. So that's how you use extend. So what else then and also let me just put, at this point you can also use the plus operator, the addition operator, right, to add two lists. If alpha is a list, A B, I've got to separate this with a comma, ABC, and we can say alpha numeric equals alpha plus numeric. So let's print alpha numeric. So it's added it, so you can add a list like that, you can do it like that, you can do it like that. So you can insert into a list. That's another way to add elements. You can insert, but if you are inserting, you have to specify the index where you are inserting, then the elements you are inserting. So let's clear this off. Let's say alphanumeric already has A, B, and let's say I want to put 1, and I want the 1 to come after A. Then I need to know the index of A. The index of A is 0, right? If I want it to come after A, that would be 1. So we can just say alpha numeric dot insert. Numeric dot insert. The index is 1, okay, and what I'm adding is 1, right? I can also add 2 if I want, dot insert. Now the position I'm using now is you know, at this point we have 1 here, so we already have 0, 1, 2, then 3. I'm using the position of 3 now. We're inserting into index 3, and then we're inserting 2. So this 3 is the position where we are putting this 2. So this 3 is the index, right? Why this 2 is the object we are inserting. That's the item we are inserting. So by that we print alphanumeric, it should have these 1 and 2. So it has those 1 and 2 like that. Alright, so if you want to remove values from a list, okay, so if you want to remove values from a list, you can use this remove, right? Now you just specify the value you are removing, but remember, lists allow repetition. So if you are removing any value, the value will be the first occurrence of that value. For instance, if I want to remove 1 from here, I can just say alpha numeric dot remove 1. If I print it, we won't have a 1 there again, so no 1 there again. So that's how you remove that. That's how you remove so we can also do this by popping, right? Now popping removes and returns the elements at a specified position, right? So but if you don't give an index, it's going to remove the last position, the last item. It's going to remove the last item, and you can save whatever you removed actually. Let's say I've not removed this. You can say alpha numeric dot pop. If you run this, you get the last item. Now remember, I did not pass anything to this bracket, so it's going to remove the last element, which is what? That should be 2. I'm going to remove 2 A, 1B, no 2 again. So but if I specify that I wanted to remove this 1 is in what index now? Is in index 1. So if I specify 1, it's going to remove 1. Yeah, it's going to remove 1. Okay, now I can save whatever I removed. Actually, I can say removed equals to alphanumeric.pop1. So it's going to give me this value. So I can say print, instead of printing the list, I can print what I removed. Print removed. I want what I removed. Print what I removed. So it's printed 1, which is what I removed. Okay. Alright. Clear. Now, what does clear does? Clear removes all elements from the list, making it empty. So it's just going to remove everything. It's going to remove everything. Okay. So let me just clear the alphanumeric. Dot clear. So you just leave these two brackets like that without passing anything into it. So if you print alphanumeric now, you're going to get nothing. So the list is cleared already. So you can also search for values in a list, right? You can search for values in a list. You can use your index. You can use your index to search for it. You can either search for the value, or you search for or you specify the index in it. So I just say my list dot index, let's say B now. Alright, so if we pass this to a variable called my index equals this. So this is just going to get the index of this for us. So if I print my index, so it's going to give me the index of this B, which is 1. It's going to give me that, which is 1. Which is 1. Alright. Now count. You can use count to return the number of occurrence of a specified value. So let's say I have a list like this that has 2, 2, 2, 2, 2. If I want to know how many 2s are here, I can just say amount goes to alphanumeric dot count. Count what now? Count 2. That's just going to give me now I'm printing what now? Amount, not my index again. I'm printing amount. So if I run that, I'm going to get 4. So that's the amount of times 2 exists in this. Okay. Ordering and copying. So you can sort a list, right? You can sort it. So arrange the list. So let's have a list like this, and let's just write random numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116 and we're going to just separate those numbers, or in fact let me write specific numbers but not orderly. Okay, now I can just say print alphanumeric dot sort. I wanted to print the sorted form of this. Now if I can, let me just run this first. I want to do something. Let's give him none. Okay, let's do it like this. Let's say alpha numeric dot sort. So print alphanumeric. Print alphanumeric. If I run this, it should give me a sorted version. So 0, 1, 2. That's arranged those items there. That's arranged it there. So you can sort items like that. You can sort the items like that. Now you can reverse the order of the elements in the list. So meaning that it's going to bring it from the back. So you can try that also. And you can copy the list. Copying list is just to copy it literally. It's going to copy it literally. So without wasting much time, let's jump into dictionaries. Now let's dive into dictionaries. So now dictionaries store data as a collection. Sorry, I'm spoiling this stuff. Okay. So dictionaries, they store data as a collection of key value pairs. What do you mean by that? They store data in pairs. So we have the key and then we have the value. How each key is unique and immutable, right? Now dictionaries themselves are mutable. Dictionaries are mutable. You can change the items in the dictionary except the key. You cannot change keys, right? So the key is unique. The key is unique. The key is unique. So but you can change the values that each key stores. So now the key can be a string, can be a number, can be a tuple, and the values can be of any data type and can be duplicated. Now the values can be a tuple, it can be a list, any value. You have any value as the values. Now dictionaries are unordered. They are unordered, unlike lists. Lists are ordered. So dictionaries are unordered. Okay. So we have this in Python versions 3.7. Dictionaries were inherently unordered, meaning that the order of items was not guaranteed. But from Python 3.7 was dictionaries maintained insertion order. So previously dictionaries were not ordered, right? But from Python 3.7, dictionaries they maintain their insertion order, so they are ordered actually. So meaning you can they can be indexed. Now dictionaries are mutable, right? Dictionaries can be modified after their creation. Elements can be added, removed, or updated. Now dictionaries are indexed by keys. You can access index values of dictionaries using their keys. Then you create dictionaries using these curly braces. Use these curly braces, and you make sure you state the key and value pairs, right? Or you use this dict constructor, just like lists. Like you can create this now. Let's go ahead and create our first dictionary. You can see my dict equals, then our curly braces. You say name. I have to put this in because it's a string, right? So name as Smith, my dict. So you have the name, Smith, and age 18. You have it like that. So what happens if I just state only the key? I don't specify the value. Let's say I just stated okay, name, only like this. What happens? Let's see what happens. You just have it like that. So you just have the key. But this is not actually an accurate. We can't call this a dictionary because dictionaries are key value pairs, right? They are key value pairs. Now we can retrieve the value associated with a specific key. So if the value goes to my dict apple, so the value will be 2. The value of this. Okay, all right. So in this at this point, apple is given the value of 2. So so this key apple was used to call forth this value. So it was used to call for this value. So if you print that, so if you come back to our dict now, let me just undo. All right, let me undo. Okay, remember the items, each of the pairs in a list in a dictionary is also separated with commas, just like list. So if I say my name equals my dict name, print my name. So it prints Smith because the name, the value of the this name is Smith. So you can get you can get the value of a particular key by inserting the key in square brackets like this. So you can use that to get a particular value. So if I replace this with age, it's going to give me 8. It's going to give me 8 like that. Okay. You can also use the get method to access a value safely, providing a default if the key is not found. So if you take a look at this, value goes to my d.get orange, 0. Okay, so now here, because orange does not actually exist in this dictionary, this 0 will be assigned to it. If you pass it to it, it will be assigned to it. For instance, if you try to say my hobby equals my get, then you have what now? Hobby, then you have coding. Print my hobby. So it gives me coding, because that is the value that I passed to it by this get. What if I just try this? You should always try to try different things when you're coding, so that you learn some new things. So that's how you learn new things. Okay, so it gives me none because there's no value for this hobby. This does not exist here. That's why it gives me that. So you can update elements in a dictionary. You can use square brackets. Okay, my dict pineapple equals to 1, so it changes the value of pineapple to 1. So this changes the value of apple to 1. So this updates method will merge another dictionary or another iterable of key values. So updates can we just take a whole bunch of another dictionary or maybe a list or a string and add it to this. For instance, if I have this already, my dict equals to this, right? If I want to add some new stuffs with the update, I can just say my dict dot update. Okay, my dict dot update. I can just put a new dictionary. So first my brackets, then this. You can just say hobby, no, as a string, right? Hobby as eating, if eating is my hobby. Let me put this also in quotes. Then favorite, let's call this favorite movie. Because it's a string, you can just write it like this: favorite movie, no movies. Favorite movie, you can call it and just call it the arrow. Okay, so if we should print my dict at this point, so it has updated the value of hobby and favorite movie to the dictionary. Okay, you can remove elements in the dictionary using the del statement. So it removes a key value pair by its key. We just enter the key and then it removes it. It removes it. It removes it. So you can remove this favorite movie by just saying my dict. Okay. Del my dict. Can just state what are we deleting now? Favorite movie. Then we got an error. Oh, you use a square bracket for that purpose. Use a square bracket for that purpose, not this. Okay. Let me just copy this whole thing into it. Okay. If I run this, so it should have removed that. So it will remove the whole pair of this favorite movie. So, and if you try to reference a key that does not exist, like maybe favorite food, this is going to throw an error, right? Key error. You have a key error there because it does not exist. The key does not exist. You can also pop, right? Pop removes a key value pair and return its value, right? You can use pop. So if you just say my dict dot pop what now? Pop hobby now. removes obi from it, but you can get what you popped by saving it in a variable. You can say removed equals to this. So let's print removed instead. If you print removed, you have the value of this obi. It gives you the value. So this pop removes the key value pair and gives you the value back. It returns the value back. Okay. Then you can also clear a dictionary. You can clear a dictionary too. So you can use len to get the number of key value pairs you have. For instance, okay, if at this point we have updated it, let's see how many we have now. You can say print len my date. So print the length of this my date. So let's run this, see what it gives us. So it gives us 4, meaning that there are 4 pairs. This, and this. So keys, now these keys return a view of object of all keys. So let's do that. Let's print key equals to my date dot keys, print key. Okay, so this prints all the keys we have, all the keys that exist in this dictionary. So values also return all the values in the dictionary as usual. Items return the pair. It returns the pair. So if you say item equals to my date dot items, and you print item. So this gives the pair, the whole pair. It returns this as a tuple. So this is how a tuple looks like. Okay, in operator is used to check whether a key exists in the dictionary. So you can check whether a key exists in the dictionary. Okay, you can say is present equals to what? Let's check for name. Name in my date. Let's print is present. So you should get a boolean value for that. True. So we get true. So what if you try to check something like try to check something like favorite food? You get false. So meaning that it does not exist. It does not exist. So you can look through keys or values or item, right? You can look through the values inside it. You can if you just use the normal iterator, it will just get the key alone. Like let's say we have all these already. We have, this is the dictionary, so we can say for key in keys, no, for key in my date, print using a for loop to print the different keys in the dictionary. So it looks through all the keys: name, age, hobby, and favorite movie. Right? What if you want to get the values? If you want to get the value, you have to use this dot values stuff. So you can just say for value in my dict dot values, print key. No, sorry, we are printing value, not key. Print value. So this is going to get the values for us: Smith 8, 18, and the arrow. That's going to get it for us. So if you want to print the two together, you just reference these two together. So this key value and then in my dict. Now instead of using dot values, you use dot items. Remember, items get the whole thing. Values by default, if you reference by with keys. So if you want to iterate or you want to reference anything, you reference with keys by default. But then you can specify using values. Then you can, if you want to reference the whole stuff, the whole pair, that would be dot items. Instead of saying dot values here, you say dot what? Dot items. I just change this for item in my dict dot items, print item, print item. So if you run this, it's going to print everything: name, Smith, both the key and the value, both the key and the value. So copy also, you can use that to copy. And we have this from keys method to create a new dictionary with specified keys and an optional default value. Sure. Okay, now let's come here. I want us to just create a very simple program. Let's call it daily goals, right? So daily goals. No, maybe daily goals list. Okay. Daily goals list. Canvas print. Can use this new line character. I say my daily goals. Let's remove this. My daily goals. Okay. You can say while true. Now this while true, we are going to create an infinite loop, right? Now while true is a simple way to create an infinite loop, meaning that continue to run this program, just continue until you discover something else, right? So while true, we are going to say it's going to continually present options to the user. So we're going to say print on a new line. Now I'm going to say print 1 add goals. Okay, I'm just going to copy this print again. Okay, so I'm going to remove this new line character so that it does not give unnecessary space. What this new line character does is actually it moves stuff to a new line, right? Let me just cut this off for now. I'll show you what I'm talking about. So if I say print before the word, if I put something like this new line character, that's the backward slash, not the forward slash. Backward slash and n like this. That's a way to put the new line character in our print stuff. So you see hello, then it jumped a line and went to word. So there's also the tab, so you can use this slash t for the tab. So let me remove this n. If I run this, say hello, then it moved word. So if this was inside hello, then slash t word. So what it's going to do is going to move the word forward. It will skip a tab and move the word forward. So that's what it does. So let's go back to our code. Let's go back to our code. Okay. Alright, so I don't need any more new lines. So this one is okay. So this will be option 2, not option 1. So option 2 will be remove goals. Then we'll have option 3. Option 3 will be view goals, and then option 4 will be exit. Okay. Alright. Now as of now, we are yet to get input from the user. We don't know what the user wants to do. So right now what it's going to do is what? It's going to create, it's going to now this will continue because we have used the what do we call it? We have used the while through, that's why it continues, but this was terminated because we have a limited memory size of 2 MB. That's why the process stopped. So actually if you are using your local IDE on your computer, it's going to be consuming memory when you continue to iterate continuously like this. So you can imagine this has consumed 2 MB. Let's clear the terminal. Let's come back here now. Now, let's get input from user first. But remember to comment your code. I can just say create an infinite loop. This, then this one is display options to users. I'm just trying to do this because it's best practice while coding to always use comments. Put an infinite loop, okay. Alright, now we are going to use conditionals to check. We are going to first collect input from the user, right? So if sorry, what am I saying now? Now we're going to say choice equals input. That's what the user enters. Input choose an option. Choose an option. Choose an option. So the user has to choose between 1, 2, 3, 4, right? Choose an option. Now if you can can comment this also. Allow the user to choose. Okay. So if choice, that's what the user enters, equals 1. Remember, this option will be a string, right? It will be a string. So meaning that if the person entered 1 as the option, we don't need to convert it to an integer because we are not doing any mathematical calculation. So if the user enters 1, what are we doing? If the user enters 1, we are supposed to add goals, right? Now there's something I forgot to do, right? So we're supposed to create a list. Create an empty list of goals. Now let's add another option here. Okay, let's continue. We'll do that again. So if choice is 1, what do we want to do? We want want to add, right? If choice is 1, here we have not created the list. My goals equals an empty list. Okay. Now if choice is 1, so how do we add to this stuff again? My goals dot append so we need to, now if the choice of the user is 1, if the user has entered add goals, so we're going to ask for what the user wants to add, right? So goal equals input, enter a new goal. So enter a new goal. Good. So now we're going to collect the goal that the user wants to enter. So enter a new goal. So the goal that the user enters will be stored as goal, right? Will be stored as goal. So we're now going to add the goal. We're going to add it. So my goals dot append what now? Goal. We're going to add whatever the user entered into it. To add it into it. So alright. So now we are out of that. Now we want to use another conditional, elif choice. If the choice of the user is not to add goals, if it is to remove goal, which is 2, what do we do? Now let's check if the goal is in it. So let's check first that is the goal that the user wants to enter. Let's ask for which goal. Okay, let's say goal equals input, enter the goal to be removed. Okay, so we're going to ask the user to enter the goal to be removed. Now it's possible a user enters a goal that does not exist, so we can say if goal in what now, if this goal that the user entered is in my goals, if the goal is present, we can just say my goals dot remove goal. So we're going to remove it. Else we're going to say going to say that the specified goal does not exist. You can just say print goal, that's whatever the user entered does not exist. Does not exist. Okay, yeah, what if when the user has added this goal here, we can say print, and we say the name of the goal, this added successfully, right? So here it has been removed successfully. Yeah. Okay, once we have removed this, we can also print this, that this has been removed successfully. Or else we say it does not exist. So if the goal is not there, say it does not exist. Now we're going to exit this state, this conditionals. We are going to leave this place. We are working at this level because we are done with this choice too. So we exit this and go back to this level. So leave choice equals what now? 3. That's option 3. So if the choice is 3, if the choice is to just view goals, what are we to do? If the choice is 3, we are going to say for goal in my goals, print goal. So meaning that look through everything that is inside my goals currently. Okay. Then leave choice equals what now? Choice 4. So if it is 4 that the person chose, which is exit, we're just going to break this loop. So if the person chose 4, which is to exit, we're just going to break the loop. So this will continue actually showing the options to users, because we have said while true I should display the options to users. So let's test what we have done. So my daily goals, we have add goals, remove goals, view goals, exit. Choose an option. If I say option 1, which is add goal, enter a new goal. Let me just say sleep added successfully. Okay, let me choose another one. Sorry, I'm supposed to choose add goals. That now I'm glad that I made this mistake, but that reminds me of what we were supposed to do. Now we are supposed to say that if the user does not enter the right choice, now we only presented 4 options. So what if the user does not enter between 1, 2, 3, 4? We are going to say, we're going to put an else here. Else, I'm going to print what? Invalid choice or invalid option. Okay, let me run this. Okay, so if I choose option 5, that's invalid option. So I'm going to choose add goals. Okay, enter a new goal, sleep. So sleep added added successfully. Then I'm going to choose to add another one. That's heat added successfully. Let me add code. No, option 1 is add code added successfully. So now let me view the goals. 3 view goals. So it says sleep, eat, code. So but instead of that, now it's just showing sleep, eat, code. I want it to show something better. So if I come back to view goals, which is option what now? Option 3. Okay, option 3. If you ask it to view goals, let it first print on a new line. Daily goals. Let me remove this my. It's not necessarily my home. Let me remove my. Okay. So if I rerun this, currently if I ask you to view goals, there's nothing, right? There's nothing currently. There's nothing currently. So in fact, let me put this here. If I ask you to view goals, there's nothing currently. So let's add. So new goal is read added successfully. Play game. Oh, sorry, I didn't choose anything. Let me choose add. Okay, enter a new goal. Play game. Play game added successfully. If I now want to view 3 view goals, so daily goals, read, play game, read and play game. So if I want to remove goals, let me choose 2. Enter the goal to be removed. If I say, let me mention an invalid goal now. I say code. It says code does not exist because it's not there. Let me choose remove goals. Let me now put read. It says read removed successfully. If I now view goals now, you say daily goals, play game. Just that alone. Just that alone. Now if I want to, what if you want to put another option for the user to clear the daily goals totally? You can say print option 4, which is what option 5, which is what delete all goals. So we add the elif here. Elif choice equals to what? 5. And just say my goals dot clear. So let's run this again. Okay, let's add goals first. So if I had sleep, if I had wake, let me choose to add. So wake added successfully. Let me choose to add again. Pray added successfully. Let me view goals. So daily goals, people. Let me clear. Let me delete all goals. So let me now try to view. So nothing is there again for now because it has deleted all the goals as at this point. But then you can print something here and say print daily goals deleted successfully. So we have our code up and running. So thank you so much for joining the class. So see you again next time.